This is chemistry 9.5 and 9.4. What are true about a catalyst? Okay, this is all in the notes. Please make sure to go over the notes. Catalysts have the same effect on the forward and the reverse. Okay, and it speeds up a chemical reaction. Does it provide a new reaction path with the same activation energy? No. Okay, what a catalyst does is basically creates a new path for the reaction that needs less energy. That's why it's faster. Okay, higher energy barrier, obviously not. It's consumed during a reaction, obviously not. Okay, catalysts are never consumed. Okay, you have to label this in the notes. It was labeling more than just this. Okay, but let's do it together. A would be the energy. See, here's the potential energy. Here's the reaction progress. A would be the this here would be reactance. So this A would be how much energy those reactants have. Then same thing goes for C. Okay, which one's the activated complex? Activated complex is always the guy at the top. Okay, and it's B. Activated energy of the forward reaction. Okay, activation energy is what separates the activation complex and the reactants or the product. Since I'm talking about the reactant, that would be the forward reaction. In case they bring it, the forward reaction is going from reactants to activate complex, but products to activate complex would be the backward. المهم, activation energy of the forward would be Y. Enthalpy change of the reaction would be the difference between the reactants and the products, and that would be X. It's separating the reactants and our products. Upon the addition of a catalyst, the value of X remains constant while the value of Y decreases. Okay, delta H doesn't change when you use a catalyst. Okay, it stays the same. The only thing that changes is the activated energy required. That's it. Okay, so the activation energy Y will change. It will decrease. It will become easy. So this reaction in this case is exothermic because the heat content of the product is less than the heat content of the reactants. Thus energy was lost. And when is it lost? لما عنا شو اسمه exothermic. Uh, the substance that speeds up the reaction rate without being consumed is called a catalyst. Okay, here you have to label the graph. Okay, which one's with catalyst, which without catalyst. Obviously, with a catalyst, it's going to become lower activation energy upon the addition of a catalyst. So you're going to take the graph with lower. The blue one would be without a catalyst because it needs higher energy. Okay, this diagram illustrates an endothermic reaction, أكيد, because the products have more energy than the reactants. And the activation energy of the forward is how much? Activation energy, you just look at the activated complex and a reactants. How much is the difference between them? It's gonna be 450. Okay, as the 550. Then the activation energy of the backward, again, same thing, but since it's backward, I just go to the products. And the difference between 700 400, that's 300. Okay, since this recording is far too short to be uploaded, I'm gonna have to choose one. I'll do some notes. So over here, okay, let me show you. Like this is how they come. So you have to label each one. Okay, I'm gonna do them quickly just in case they come. C would be, okay, I'll start with A. A would be potential energy. B would be the reaction coordinate. C would be the reactants. D would be the products. Okay. H would be what would H be? The activation energy of the back. Sorry, why did I go to H? A, B, C, D, E. E would be the heat content of the reactants. F would be the heat content of the product. G would be the activation energy of the forward because I'm going from the reactants to the activated complex. That's the activation energy. Okay, you have G, H. Now again, H is also the activation energy, but it's the backward because I'm going from the products to the activated complex. I would be the activation energy, sorry, the energy of the activated complex. Okay, I represents the energy of this activated complex. Sometimes they're gonna ask you calculate the values. يعني مثلا E, how would you calculate the value of it? You just, it's gonna be 525. Or how do you calculate delta H? Delta H is J. I skip J. J is delta H between C and D. How do you calculate? You subtract 525 by 175. Okay. The overall reaction is, in this case, exothermic because released energy, and delta H, whatever. Okay. What is a catalyst? We said it's a substance that increases the reaction rate without being used up. It speeds up both the forward and the reverse. Okay, you have to know a catalyst takes part in the reaction, but it's regenerated, so it's not used up. A catalyst acts how? It provides a new path that has lower activation energy for reactants to follow, so the catalyzed and uncatalyzed pathways proceed simultaneously. Okay, so what happens is this catalyst, it comes, it creates a new pathway. Okay, like an extra, it opens a new road. Like for example, imagine you have a road that has traffic, okay, and there's a lot of cars, okay. I know what I did is, amidst all the traffic, I went and opened up a new free road on the side, so people start using that free road, right? Okay, that's the same thing with the catalyst. It will be very slow, okay, the reaction, and then when you add the catalyst, okay, it creates a new path to follow. People will still use the old path, but people also start begin to use the new path as well. Okay, so that's why we say there are still going to be some slower parts of the reaction, but most of it will be sped up because of a catalyst. Uh, where else can what else can I do now? These questions are all important. They come, yani. Okay. Uh, here, this one. I think this one will come. How do you know which one's the catalyst? Okay, the catalyst is the one that was used up, but it's regenerated. Remember, they said that the catalyst is takes part, but it is regenerated, so it's not used up. So where do I have something that was taken up but regenerated? It's gonna be H plus, because here H plus was used, then here H plus was produced. Okay. The graph shows if it's okay. These are easy. These are, yeah, these are easy. Without, okay, so yeah, without the exothermic reaction, without the catalyst, then with the catalyst, okay, the activation energy would be much lower. You see, then here, same thing here. Endothermic, it would be a lower activation energy. Okay, you can get this. Just the kinetic energy increases as you go to the right. Okay, yeah, I mean, I guess we're done here. Let me one more minute. What can I talk about? Okay, these are all the questions that come in the quiz. Okay, you know what? I'll explain the kinetic. Okay, here this is what we call the Maxwell-Boltzmann distribution curve. Okay, basically what he said is, as temperatures increase, kinetic energy increase. So as temperature increases, all you have to know is the shaded area, the shaded region will uh increase, of course, because shaded region means there's more kinetic energy. Whatever, blah 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 blah. Let me think of something else I can talk about. Yeah, so here, مثلا, the shaded area presents a number of particles with kinetic energies equal to or greater than the activation energy. With a catalyst, the area would have increased. Okay, this means the number of particles with kinetic energy equal to or greater than the activation energy increased. Okay, this is important. As a result, the number of active collisions increase, and so does the rate of reaction. Okay, blah 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 blah. Okay, I think خلاص we're done. Thank you so much for watching. Uh, good luck.